Hello and welcome to this episode of engineering maths. We are going to be doing substitution method under differential calculus. We've done the direct integration method, we've done the separating variables method. Now we are on the substitution method. And before I go on, if you are a viewer of this channel and you enjoy these benefits, it is very good for you to subscribe, because I noticed that the number of viewers are actually more than the subscribers. The only way you can help us to promote our videos on YouTube is to subscribe to our channel, like, comment, and engage fully in it. So thank you very much. Step by step, I'm going to be explaining this question. Wait till the last one, because the last one is very complex. Thank you very much. Now, when you are using substitution method, you have to take the complex part of that equation and differentiate it and represent it with a particular letter that you can use to cancel it in the other way around when you want to solve it. So briefly now, the complex part here is x squared, and how am I going to represent? I can choose to represent that with u. So I'll just say u equals to x squared. Next thing I'm going to do is to differentiate that u. So I will say is u with respect to x. I will say du dx. This is 2x if you differentiate it, right? 2x. So I'm having dx here. I will also look for another way that dx is equals to. So what am I saying? From this dimension I got here, I will make dx subject to the formula. So when I do that, I will have du is equals to 2x dx. Then here, dx will be 2 du over 2x from here. So I'll just say dx is equals to du over 2x. So now that I've gotten dx, now I can now come and insert it here. Then I will represent my x squared as my u. Do we get? So now I'll be having, the equation now becomes 2x cos u dot, what's our dx now? Du over 2x. If you are with me, you are going to see that this 2x will cancel this 2x here. So like that, we are going to be having a direct integration. So we just say cos u du. And if you integrate cos, we all know that if you integrate cos, it's going to give us sine. So that will be equals to sine u plus c. So that's for this question here. Let's quickly move to the second one. Like I said, represent the complex part with a particular letter and differentiate it. So the complex part here is what? 2x plus 1, right? So I will just say let u, you can use another letter. It's not compulsorily because you must use u, but it's because u is very familiar with us. So 2x plus 1. Now I want to differentiate this. That will be du dx. If you differentiate 2x, that will be what? 2. So my plan now is to make dx subject to the formula, and that will be what? Du over 2. If you follow the steps that we use here, I don't want to waste our time. So that will be dx equals to du over 2. Now we are rewriting the equation. It will now be represented, this 2x plus 1 will be represented by u, and our dx also will be represented by this. So let's move on. We're going to be having integration of 3 into brackets, or let me just put u since it's a single variable. Then our dx, we are not forgetting our dx, du over 2. So you can see that nothing can cancel here, right? So it doesn't mean you have to bring that 2 or under this 3. So you just say 3 over 2 raised to power 4, then du. Then when you are doing the integration, the constant is going to come outside. So you're going to be saying 3 over 2 integration of u raised to power 4 du. So you are facing this u raised to power 4, and if you do that, that will be u raised to power 4, it will be u raised to power 5 over 5. Remember the law that you used to integrate. So plus c, right? Now just use the normal multiplication here. 3 multiplied by u raised to power 5 and 2 multiplied by 5. So that will be 3 u raised to power 5 over 10 plus c. And now you can just input back your u. You can just input back your u. So it will be 3 into brackets. What's our u? 2x plus 1 raised to power 5 over 10, then plus c. Here too you can input back your u. I'm sorry I omitted that. So you just say sine, what's our u here? X square plus c. So this for this for this. And now in this part, still the same process. Represent the complex part by a variable. So I say u is equals to x square plus 5. So I differentiate the u dx is equals to 2x, right? 5, you cannot integrate 5, it will give you nothing there. So I will just bring dx as subject of formula here. So I'll be having dx equals to du over 2x. So I rewrite the equation, right? I'll be having 2x over, I've represented this as u, right? So I'll just put u here. Then I'll represent this dx by du over 2x rather. So from here we know that 2x will cancel 2x, right? So we are having du over u left, du over u, which is still equals to 1 over u du. And when you are integrating 1 over anything, it's going to be ln of that variable. So you just say equals to ln u plus c. Now what is u? X squared plus 5. So ln is equals to x squared, ln x squared plus 5 plus c. So that is that. So we are going to move on to this last one. This last one I want us to pay very close attention because it's a bit complex. Now this is the last question, and it's also substitution method, but it's a bit different. Now we are given dy dx is equals to x plus y over 3x. Firstly, we are going to check the homogeneity of this equation. And how do we do that? We just split this 3x into two places. You know, the 3x is for x and it's for 4y. So we are going to be having x over 3x. You just say x over 3. You are facing this side for now. 3x plus 4 over 3x. We all know here that x will cancel x here, right? And we'll be having 1 over 3. So we just say 1 over 3 plus 4 over 3, 1 over x. Y rather, I'm using y. It's supposed to be y, not 1. Y over x. So I've splitted it. Now this y over x, I'll make v equals to this y over x. I'll make v equals, I want to make, I said you'll be using the complex part, you'll be representing the complex part by a variable. So I'll just say let v equals to y over x. So I'll just make y the subject of the formula. So y will now be equals to vx. You will see the reason why we are doing this when we move on. So now we have to use the product rule, and we are using it from this place. Many people just go straight to the product rule without knowing how they get it, but I'm going to explain it here. Product rule is like when you integrate the first differentiate the first variable, you are not differentiating the second one, then plus when you differentiate the second variable, you are not differentiating the first one. So that's just the logic. Now there's multiplication here, and dy dx will be, now I will not differentiate this, I will differentiate this. So that will be v dx over dx. That means I'm differentiating this x here. So plus, I've not differentiated this before, so I just say dv dx multiply by, now I'm not differentiating x again, x. So if we are going to be having v plus differential of x will give us 1, so we are not having anything there again. So dv dx and x, so I'll just say x dv dx. So this is how we came about this formula, product rule, in our notes. So now we are going to be equating this to this. Since now this is the dy dx, so we are equating this dy dx to the equation. So we are going to be having v plus x dv dx equals to x plus 4y over 3. Remember, we use y as vx here, so we are going to come back here and come and insert it here. Let me just write it so that we don't get lost. Let y equals to vx. So I will now put vx here. So in that place, we are going to be having v this on this left hand side, then equals to x plus 4 vx. Now y is already vx now over 3x. Please play I want us to pay close attention. So now we are factorizing x in this place. You know that x is common here and here, so we want to factorize it out. We are having v plus x dv on this left side. So here factorizing x out, I'll be having x into bracket 1 plus 4v over 3x. So we are all familiar with that. We know what I did there. I just factorize it out. So after that, I can subtract v. I want this v to come here because it has a relation here. It has work to do here. So I will just say x. I'm bringing this v here, so that will be minus v on this side. X dv dx is equals to I omitted something here. This x will cancel this x. I'm sorry about that. So this x will be cancel this x, and it will remain this 1 plus 4v over 3. So here now we'll be having 1 plus 4v over 3. The v are already coming, so we'll be having minus v, right? So now we are using common denominator of 3. And what is the meaning of that? We are going to make this also have a denominator of 3, but you will not let it seem as if it's a different equation. So you just say 3v over 3 in a way that if you cancel 3 here, cancel 3 here, to still remain that same v. So you are going to be having x dv dx equals to 1 plus 4v over 3 and minus 3v over 3. Why are we doing that? Because we want to use LCM here, and we are all familiar with that. So it will be equals to 3. So this will be 1 plus 4v minus 3v. We still have our left side untouched. So here we'll be having 4v minus 3v will be v, right? 1 plus v over 3, and we still have our left side to here. So now what we need to do is multiply both sides by 3. Multiply both sides by 3. So we are going to be having, if we multiply both sides by 3, we are going to be having 3x dv dx is equals to 1 plus v. So we are going to be using separating variable now. You see that we are going from one method to another. It's not hard if you are going to calm down. So it's very simple. So let me just write it here so that we don't get lost. Separating variables. The reason why I'm writing this step so that you can know what we use there. Separating variables. And we've done that in the previous video. All the related v will come to one side, x will go to the other side. So we'll be having, let's do it step by step. Okay, let the x come here. So I'll be having 1 plus v dx. Now the v can come here, and the 3x can come under the dx. So I'll be having the v over 1 plus v is equals to dx over 3x, right? Now you can now integrate both sides from here. You can integrate both sides. So when you integrate both sides, you'll be saying integration of 1 over 1 plus v dv and integration of 1 over 3. Then we still have another 1 over x here. So 1 over x dx. So this one will be ln of 1 plus v. Then here the constant will come outside, and if you integrate this, that's ln x plus c. Yes, ln x plus c. Now what are you doing? Multiply both sides by 3 again. So you'll be having 3 ln 1 plus v is equals to ln x plus c. Yes. Now we are inserting v is equals to y over x here. V is because it's going to lead us to logarithmic function. So you say let v equals to y over x. This is not new. I think we have done it here before. So now we just insert that here. So we'll be having 3 ln 1 plus y over x, then equals to ln x plus c. So that is what we have there. So now we are going to be using the common denominator again. We are going to make this x common here, and that will be 1x over x. So we'll be having 3 ln x over x, or 1x over x, still the same thing, plus y over x. Then we'll be having ln x plus c here. I think we are clear here. So now we can use LCM here. So it will be x plus y over x in that way. So we're having 3 ln x plus y over x. Then we'll be having ln x plus c. We are already there. So now this is where we are going to use the logarithmic function. For when you are using log property for ln a over b, the result is going to be ln a minus ln b. We are all familiar with that. So you just say, using, should I write it there? Let me write it there. Using, if you are having ln a over b, it will be ln a minus ln b. So it's because of this we are doing that. So if you are doing that, that's going to be 3 into brackets. We are facing this now. Ln x plus y minus ln x equals to ln x plus c. So you can multiply, open the brackets. You'll be having ln 3 ln x plus y minus 3 ln x is equals to ln x plus c. And from there, you can see that 3 ln x and ln x, they are common, so you can bring them to the other side. So it will now be 3 ln x plus y. That will be 3. If 3 minus 3 comes here, it's going to be plus. So that will be 3 ln x plus ln x plus c. So our final answer will be what? 3 ln x plus y is equals to 3 ln x plus ln x. That will be 4 ln x plus c. So this is the end of this video. You can see that it's a very long process, but I try to break it down step by step. So thank you very much. Like, share, comment, subscribe. And if you view this video and you see that it's very, very helpful to you, please don't hesitate to click the subscribe button on your page. So thank you very much.